In section 3.1, we want to talk about the trigonometric identities. Chapter 3 is all about trig identities and using trig identities for solving trig equations. But let's get familiar with all the trigonometric identities first. So you can see many of the fundamental identities in trigonometry. We have reciprocal identities, which we already talked about that one, are the identities that we have used them and we said that the secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent, tangent is 1 over cotangent, and cosine is 1 over secant, sine is 1 over cosecant. We also have the quotient identities. Quotient means division. We have dividing, and that is those identities are for tangent and cotangent because we can find tangent by dividing sine by cosine, and then divide cosine by sine gives us cotangent. It means that anytime you want to use this identity instead of tangent, you can replace sine over cosine. We also have Pythagorean identities. Those identities are the identities that comes by um, adding two squares. For example, sine square plus cosine square, which is always equal to 1. That's one of the Pythagorean identities. Or we say 1 plus tangent square is always equal to secant square. 1 plus cotangent square is always cosecant square. And the proof of all of them is on the textbook if you want to look at, but we don't need to know them. We need to know how to use this identity when we are solving problems. And we also have even odd identities, which is about the functions that are even or odd. And we know that odd function like sine, like cosecant, like tangent, like cotangent, when we have a negative angle inside the parenthesis, the negative can be out. But if we have odd functions, if we have even function like cosine and secant, even if we have negative angles, negative doesn't change anything. So we still get the positive cosine of x. So the cosine of negative x is equal to cosine of x. The negative for the angle doesn't change anything. We still get the same result because that's the even function. But if it's odd, we will have a negative outside. Now, I recommend you just print one page of this and have it in front of yourself when you are solving problems, because you always need to check the identities when you are verifying other identities or you are solving equations. So if we want to verify any other identities, we always need to start from one side of the equation, one side of the identity, and try to replace some other identities, some of the fundamental identities, and simplify and try to get the other side of the identity. And sometimes in some problems, we need to work on the both sides to show that they are identical and they are equal to each other. The left side is equal to the right side. So we are going to substitute one or more fundamental identities, usually on the complicated side. It doesn't matter which side you start. You can start on the right side or left side, but we always start with the complicated and the side that has more function in it, because it let us to have more functions to work on. For example, we want to verify this identity. Verify this identity means we want to show that the right side is equal to the left side. So I have to start from one side, replace some fundamental identities, simplify, and get the other side. So it doesn't matter which side I start, but I always start with the more complicated side, and right now in this one, it's the left side. So in this one, I prefer to start from the left side, replace some identities, simplify, and at the end, I want to show that is equal to the secant of x, which is the right side of my identity. Since the right side, I have secant, I need to use some of the identities that makes the left side into the secant. But let's see what we can do as a first step. So first of all, I'm going to use from the left side, I have cosecant and tangent. What formula do we have for cosecant? So for cosecant, the only formula that we have is this one, 1 over sine. And for tangent, the only form, we have two actually formulas. We have this one and we have this one. But we need to see which one works better. And remember, when you are verifying identities, sometimes you may use some identities, replace it, simplify, and do it. And at the end, you see that you don't get the answer that you're looking for. So don't afraid, erase everything and start over. Use other identities to replace. That is something that for everyone happens. So don't get disappointed if you don't get the answer. It means that you need to use other identities or pick a different strategy to get the answer that you are looking for. So right now, I want to replace 1 over sine for cosecant. And since I am changing cosecant to the sine by replacing 1 over sine, I prefer to replace the tangent by sine over cosine as well, because that gives me a chance of simplifying. So if I replace the cosecant by 1 over sine and replace the tangent by sine over cosine, and I know that's a multiplication between them. So I have two fractions that needs to be multiplied. And I know for multiplying two fractions, if there is anything to simplify or cancel out, I can do that. Otherwise, I need to multiply the numerators together and the denominators together. Right now, these two fractions, I see a sign on the numerator and a sign on the denominator, which means I can cancel the sine x by sine x. So what's left over now? Just 1 over cosine. And I know based on the other trig identities that the 1 over cosine is always equal to the secant. Okay, I'm done. I started from the left side, replace identities, simplified, and I ended up to the right side. And I showed that the left side is equal to the right side. This is how we verify any identities. Let's look at another example. So we have this identity and we want to verify the identity by using fundamental identities. So I prefer to start from the left side again because I have more functions on the left. And when I look at the left side, I see sine minus sine times cosine squared. And I expect to replace formulas and make everything to the sine because the right side is just sine x. Which means that cosine squared also must be replaced by a function that has a sine. But let's see how we can do that. I see a negative, which means I have two terms, one term, two terms. And I see sine is a common term between these two terms. And every time you see a common term, so you can factor out that common term. So I can factor out the sine x out of this identity on the left side. And if I factor out the sine from the first term, when you factor, that means you are dividing by that. When you factor sine, that means you are dividing both terms by sine. And if you divide both terms by sine, sine over sine is just 1, and the sine and sine cancel each other, and you will have only cosine squared. Now, let's see what we can do now. This expression inside the parenthesis is familiar for me. I know I have one trig identity for 1 minus cosine square. What is that? So you learned about the Pythagorean identities, which one of them is sine square plus cosine square, which is always equal to 1. Now, from this identity, if you keep the sine on the left side and move the cosine to the other side, you get 1 minus cosine square, which means every time you have 1 minus cosine square, you can replace it by sine square. So for the whole thing inside the parenthesis, you can replace sine square. And don't forget, you also have a sine out of the parenthesis as well. And now I can multiply sine by sine square because this is a sine with the first power, the parenthesis has a sine with the second power, and if I multiply them together, give me sine with the third power. And I'm done because I have the right side of the identity now. So this identity verified. Okay, let's look at another example. I try to pick different forms of the identity to let you see all of the options that we may have and the strategy that we may pick to verify the identities. To verify this identity, to show that the left side is equal to the right side, I prefer to start from the left side because I have more functions on the left. Okay? And if I start from the left side, I see two fractions that are adding together. Two fractions adding together means I need a common denominator. For adding two fractions or subtracting two fractions, I always need the common denominator. Now the question is, what is the common denominator between these two denominators? My first denominator is 1 plus cosine, and since there is an addition between them, you always keep them in parentheses because whenever you have add or subtract on the numerator or denominator, you cannot cancel anything. And you can keep the whole things inside the parenthesis to remind you that that whole thing is just works as a one term, and the second denominator is sine x, and the common denominator between the two terms that don't have anything in common is just the multiplication. So the common denominator right now is sine times 1 plus cosine. Okay? And if you find the common denominator and start writing the fractions, you know that you always compare the denominators with the common denominator. If you compare the first denominator with the common denominator, you see that you are missing sine, and which means I need to multiply by sine. If you compare the second denominator by the common denominator, you are missing the parenthesis, so you need to multiply by 1 plus cosine, and we do the same on top as well. Now let's multiply. So don't multiply the denominators, just keep them as a sine times 1 plus cosine because it's in the factor form. And if we simplify the numerator, we may be able to simplify something. So let's keep the denominator the same, but we need to multiply the numerators and then add them together. If I multiply sine by sine, I get sine squared. And if I multiply 1 plus cosine by 1 plus cosine, remember you have two terms in the first parenthesis, two terms in the second parenthesis. So you have 4 multiplication and you need to multiply them all together. 1 times 1, which is 1. 1 times cosine is cosine. Cosine times 1, which is cosine. Cosine times cosine is cosine squared. And if you combine the like term, you get 1 plus 2 cosine x plus cosine s squared. Now we will write these whole things on the same fraction with the common denominator. Okay, now let's look at the numerators. Is there anything that we can simplify or add them together or replace them with anything else, with any other identities? When I look at the whole numerator, only numerator, I see that I have a sine square plus cosine square. And it reminds me one of the fundamental identities, because one of the fundamental identities tells me that the sine square plus cosine square is always equal to 1. So you can remove these two and just put 1. So we will have 1 plus 2 cosine. So replace these with 1. And now you have 1 plus 1 plus 2 cosine, and 1 plus 1, you can combine like terms. It gives you 2 plus 2 cosine on numerator. Now, when you look at numerator, do you see anything? Because right now in numerator, you have two terms. One term and two terms. Is there anything in common between these two terms? Yes, the 2 is in common, which means you can factor out. I told you, anytime you see a common term between some terms, just factor it out. And if you factor 2, you get 2 times the 1 plus cosine. And you see that that's exactly the same as the denominator. And when you have something in parentheses like this one on the denominator, you are only able to cancel it out, the whole parenthesis or nothing. So you cannot cancel only the cosine by cosine or 1 by 1. When something is in a parenthesis, the whole thing must be canceled together. Okay, you cannot look at the terms inside the parentheses separately. And we have 1 plus cosine in the numerator and 1 plus cosine in the denominator. If we cancel them together, cancel out, we get 2 over sine x. Okay, but I expected to get, let's see, what do we have on the other side? The beginning of the question, we had 2 cosecants. So I expect to get 2 cosecants. So how we can change it to cosecant? So you have 2 over sine, which means you can rewrite this one as a 2 times 1 over sine. And 1 over sine, based on the reciprocal identities, is always cosecant. So it means you are done. You verified the identity and you got the right side. Okay. Next example. You want to verify this identity. Again, I'm going to start from the left side. And on the left side, I see 2 fractions with the addition in between. That means I need to add the fractions. For adding fractions, I need to find the common denominator. To find the common denominator, I need to look at the denominators, but I see addition. I see 1 plus sign or 1 minus sign, and there is nothing that I can add together. So I have to put them in a parenthesis. That tells me the whole thing must be ones or nothing. Now, if you want to find the common denominator, you just need to multiply the denominators because there is no common denominator. And if you multiply the denominators, for writing the common denominator, you can just keep them as a 2 parentheses like this and change the numerators. Since you multiplied the first denominator by 1 minus sign, you multiply the top by 1 minus sign as well. Then you multiply the second one by 1 plus sign, multiply this one by 1 plus sign as well. And if you multiply and then write them all in the on top of one fraction with the common denominator, you get 1 minus sign plus 1 plus sign. And plus sign and minus sign cancel each other, and you get 2 over the whole denominator. As I see on the right side, I have tangent. So how can I change this one to tangent? So now, since we want to get tangent on the right side, maybe it's better when we multiply the common denominators. If we multiply 1 plus sign with 1 minus sign, we get 1 minus sine square, because 1 times 1 is 1, 1 times negative sign is negative sign, positive sign times 1 is positive sign, and positive sign times negative sign is negative sine squared theta. And positive sign and negative sign cancel each other, and we only have 1 minus sine square for the denominator. And I know one of the trig identities that this 1 minus sine square is always cosine square. So remember, 1 minus sine square is always cosine square, and 1 minus cosine square is always sine square. So you can replace 1 minus sine square with cosine square. Okay, now how we can get 2 plus 2 tangent square? I'm not sure if we can get tangent from this. I prefer in this case to leave this one right now and start working on the right side now. I told you sometimes you may need to work on the both sides. If we start working with the right side, so on the right side we have 2 plus 2 tangent square. And you know that you can replace the tangent by sine over cosine, which means the tangent square is sine square plus cosine square. Then we will have 2 plus 2 sine square over cosine square. And again, we have two fractions, and I need to find the common denominator between them. And the common denominator is cosine square. And if we find the common denominator and multiply this by cosine square, we get 2 cosine square plus 2 sine square on top. I told you, anytime you see something in common between some terms that are adding or subtracting, factor it out. Right now, I see 2 is in common between these two terms. So I can factor the 2 out. If I factor the 2, I get cosine square plus sine square. And based on the trig identities, I know cosine square plus sine square is always equal to 1, which means 2 times 1 is 2 on top. And for the bottom part, we have cosine square. We can keep it as a cosine square, or you can rewrite it as a 1 minus sine square. So right now we have 2 over cosine square from the right side. And if you remember, we got 2 over cosine square from the left side as well. When you get something the same from both sides, that means you also verified the identities. Because right now, the left side and the right side are equal. Both of them are equal to 2 over cosine square. Sometimes by working on one side, we can get the other side. Sometimes we may need to work on both sides, like this problem. So in this slide, it's talking about some guidelines for verifying trigonometric identity. So first of all, work with each side of the equation independently from the other side. When you're working on the right side, just work with whatever you have on the right. Don't look at the left side. Or if you're working on the left, just work with that left side without including the other side. Okay, we always start with the more complicated side. Sometimes it's the left side, sometimes in the right side, and we replace functions, we simplify and do all the steps to get the other side. You may need, there are some techniques that you can use when you're verifying identities. Sometimes it's better to rewrite the more complicated side in terms of sine and cosine because we have more formulas for sine and cosine to simplify and replace. Sometimes you may need to factor a common factor out of the 2 or 3 or more terms. Sometimes you also may need to separate one single fraction into two fractions. For example, if you have a plus b over one single term and on the denominator, you can rewrite it as a two separate fraction. So we have the opposite other side as well. Sometimes we have a over c plus b over c, and you see c is the common denominator, so you keep the common denominators and add the numerators. Sometimes you have these, you have some terms are adding or subtracting top of one single term at the bottom, and to simplify, maybe you need to back to the separate fraction, and instead of keeping these, just rewrite it as a over c plus b over c, and you will see in the examples. And that's what I told you. You need to find the common denominator sometimes. And sometimes you also may need to multiply the both numerators and denominator by a binomial factor, which is called conjugate. And I will show you an example. Conjugate is, for example, you have 1 over sine minus cosine. And I don't have any formulas to replace for sine and cosine at this time. So what do? I start multiplying by the conjugate. And the conjugate means the same terms with the opposite sign. Instead of sine minus cosine, I put sine plus cosine. And don't forget that anytime you're multiplying denominators, you need to do the same on top. So the numerator also must be multiplied by the same thing. Because if you multiply both top and the bottom by the same things, it means you actually did nothing because they can cancel out each other, and that's actually nothing. But make sure that both of the numerator and denominator for the conjugate part must be exactly the same. And don't be afraid to stop and start over again and again if you're not getting anywhere. Okay? So that is something that always happens when we are verifying identities. Another example. So we want to verify this identity. If you look at the identity, you see the sign of negative x, which tells me that's that's the time that I need to use even or odd identities. Anytime you have a negative for the angle, use even or odd identities. And since sine is an odd function, instead of sine of negative x, you can have negative sine of x. So I keep the first fraction, and instead of sine of negative x, I put negative sine of x. And I started from the left side, and I want to simplify this side to get the right side. So what we can do on the left side, you see two parentheses with the multiplication in between. That means, okay, you should multiply them. There is no other thing that we can do except multiplying. So let's multiply the parentheses. 1 times 1, 1 times negative sine, sine times 1, sine times negative sine. Sine times sine is sine squared. And after multiplying, first of all, there is no more parentheses. And then I am able to combine like terms, and these two are like terms, but sine minus sine, like 2 minus 2, they always cancel each other. And the only thing that I'm left with is 1 minus sine squared. And I remember one to read identity for 1 minus sine squared, because 1 minus sine squared is always cosine squared. And you see, by simplifying and replacing trig identities on the left side, I ended up to the right side. And I'm done. I put all the formulas here for you to review again. So let's look at another example. This time we want to simplify the expression by rewriting and using the identities. Okay. There is no other side. We just want to simplify. That's it. And simplify to see what's the simplest form of this expression that we can get. I have a cosecant square and I have a cotangent square. Let's go back to the slide of all trig identities. What do you think? What we can replace for cosecant square? By knowing that the other function is cotangent square. So I prefer to replace something for cosecant that helps me and let me to add or subtract with the cotangent square, okay? And when I look at the trig identities, I see this one. This identity tells me that the cosecant square is always 1 plus cotangent square. It means that instead of cosecant square, I can replace 1 plus cotangent square. So bring down the rest of the problem. Negative cotangent square. What else we can do? We have like terms. We can combine like terms. Cotangent square. We can combine them, but since one is positive, one is negative, they cancel each other. And it is 0 actually, and 1 plus 0 is just 1. That's the simplest form of this expression.